All right, so we're going to go over the mole test review, question 13 and 14, and see if we can work these out. So these questions are both concentration of solution type questions. So they're going to use the two equations that we need for finding the strength of a solution, the molarity of the solution. In number 13, we're going to use molarity is equal to moles over liters. And for 14, we're using the other equation, which is MC VC is equal to MD VD. The C's stand for concentrated, and the D's stand for dilute. Okay, so we'll get into both of these here in a second, but it's important to remember that molarity is the big M, moles is MOL, and liters is your volume. Okay, so for this equation, we know everything except for moles, okay, because we know the molarity is 3, and we know that the volume is 0.5, the liters is 0.5. So what we're solving for is moles. They don't want moles though, they want grams. So we're going to convert it to grams after we get moles. But let's adjust this equation to solve for moles. So we have, if we multiply each side by liters, then we have moles would be equal to molarity times liters. So let's figure out what that is. So our molarity is 3. And our liters, like I said, is 0.5. So that's 1.5 moles. 0.5 times 3 is 1.5. All right, that's moles though. So we have 1.5 moles of NaOH. 1.5 moles of NaOH is is how we get grams. Because we want to know grams of NaOH. That's what they want to know. So to convert from moles to grams, we use the conversion that we talked about before. If you remember when we did mole conversions, it was grams, moles, volume, and parts. And we had a way to convert between each one of these. The conversion between moles and grams used the formula mass, or FM. Formula mass is different for everything. We have to calculate the formula mass for specifically NaOH. So we're going to use our periodic table to find the formula mass of that. The other conversions that we have to worry about are the parts. This one doesn't do this, but it's 6.02 times 10 to the 23rd. And the other one that you have to be familiar with is the conversion to volume, which is 22.4. Remember, if you're going 2 moles, it's always going to be divided by those constants, but we're not. We're going 2 grams. So we're going to multiply by the formula mass. And it would be a multiplication problem if you're converting to anything else, be it volume by 22.4 or parts with the 6.02 times 10 to the 23rd. But we're just doing NaOH. So for NaOH, where's my board markers? Too many shelves in here. Kind of wanted to do that in a different color. Huh. I have green. That's not going to show up. All right, so if you look on the periodic table at Na, the formula weight is 22.989. So that's rounded off to a 23.0. Then we have oxygen. Oxygen is 15.994. So that's going to round up, oxygen right here. That's going to round up to 16.0. And then we have hydrogen. Hydrogen's way over there. It's got a weight of 1.0079. So that's pretty much 1.0. So 23 plus 16 is 39, plus 1 is 40. So this has a formula mass of 40. 40 grams per 1 mole. So we're going to take the 1.5 moles of NaOH and we're going to multiply it by 40 to find the amount of grams, which is 60. So you need 60 grams. 60 grams of NaOH in order to make that solution. All right. So that's how that one works. That's using your molarity is equal to moles over liters. We have liters, we have molarity. You can find moles from that, but they want in grams. Use the formula mass to convert to grams of NaOH. All right, let's look at 14. 14 is different. It uses a different equation because you're starting with a 12 molar concentrated solution and you want it to be, a quarter strength. Instead of using 12, you need 3. And you need 100 milliliters of that solution to make it work. If you look, we're really looking for the volume that you need to mix to make that work. Okay. So the equation we use is MCVC is equal to MdVd. MC is molarity concentrated. VC is volume concentrated. MD is molarity dilute, and VD is molarity dilute. Dilute is referring to the lesser strength and the volume that goes along with that. So really the only one we don't know is this. We don't know volume concentrated, so we need to solve for volume concentrated. So if we divide both sides by MC, you end up with volume concentrated is equal to molarity dilute, volume dilute, over molarity concentrated. So setting that up, molarity dilute is 3 molar. Volume dilute is 100 milliliters. So you have to multiply that. This one can be in milliliters, by the way. This one can't. This one has to be specifically in liters. So sometimes you have to do a conversion, but in this one, it's just straightforward. You can be in milliliters, then your answer actually comes out to milliliters, which might be good. So, and it's starting with a 12 molar solution. So this is 1/3. So really it's just 1/3 of 100 milliliters, if you want to think of it that way. And so 1/3 of that is 25, 3 over 12. 3 over 12 is, 0.25. It's a quarter. Why did I say a third? It's a quarter. So so you take 25 milliliters of that. All right, let me just make sure I answered that whole question. 14. How much of the concentrated HCl would you have to use to make that solution? Yeah, you'd have to use the 25 milliliters of that, and then you'd add enough water to get 100 milliliters total volume. Okay, so hopefully that helped with question 13 and 14. I know there are a lot of questions about those, but that's how molarity and concentration works with mole problems. All right, thank you.